So today we're going to be looking at how the number of nuclei varies with time due to decay. So the first term that we need to go over is what is activity. Now activity is the rate of decay of nuclei. So if we say that activity is A, that is equal to minus dn by dt. Now, dn by dt is your rate of change in nuclei, and there is a negative sign because the number of nuclei is decreasing. Now, activity is actually proportional to the number of nuclei. That means that the more nuclei they are, the more the activity is. So we can basically say that the activity is equal to some constant times n. So if we put that up here, we get that this is equal to lambda n. So that here is your activity equation. And let's actually examine this part of that equation. So we know that minus dn by dt is equal to lambda n. And if we times both sides by dt and divide by n, we get that dn over n is equal to minus lambda dt. Now this isn't really proper maths. So what we have to do is stick an integral sign in front of the d variables. So we get this equation, and if you were to integrate this equation, you would end up getting that n is equal to n naught e to the minus lambda t. Now, n is your number of nuclei at a particular time t. N naught was your original number of nuclei. Lambda is something known as your decay constant, and t is obviously your time. Now your decay constant, which is also known as lambda, is the probability of nuclei decaying per unit time. And your decay constant lambda varies for different substances or elements or nuclei. Now let's look at something known as the half-life. We're going to call this T half. Now the half-life is the time taken for the number of nuclei to halve. So let's say we started off with n naught nuclei. After a time of t half, which is after a time that is equal to your half-life period, your number of nuclei is going to be equal to n naught over 2. So let's actually plug that into our decay equation. We know that n is equal to n naught e to the minus lambda t. At t equals t half, n naught over 2 is going to be equal to n naught e to the minus lambda t half. Now we can cancel these. So we get a half is equal to e to the minus lambda t a half. And if we take the natural log of both sides, we get that ln of a half is equal to minus lambda t half. And if we actually do a bit of rearranging, we can get that t half is equal to ln of 2 over lambda. So we can actually see that the half-life is solely dependent on the decay constant. So this lambda value determines what the half-life of an element is. Now this graph here depicts what a decay of nuclei would look like. This here is an exponentially decreasing graph. Now after a time of one half-life, the number of nuclei which starts off at n naught, this value here would drop to n naught over 2. And after a second half-life, this value here would then drop to n naught over 4. So as you can see, after each half-life, after one half-life, after two half-life, after 3, the number of nuclei keeps halving. So let's look at our decay equation one more time. We have n is equal to n naught e to the minus lambda t. Now let's say I wanted to plot a straight line graph to make it a bit easier to analyze. What I can actually do is take the ln of both sides. So if I say that ln n is equal to ln n naught e to the minus lambda t, I'll get that ln of n is equal to ln of n naught minus lambda t. And what I can actually do is I can actually now plot a graph of ln of n versus time. And this would be our straight line graph. Ln of n would be on your y-axis. T is your x variable. Your gradient would be equal to minus lambda, and your y-intercept would be ln of n naught. So this graph would actually look something like this. You can see ln of n on the y-axis, time on the x-axis, with a y-intercept of ln of n naught, and this gradient of the graph here is minus lambda, which is your decay constant. So if in a certain scenario you wanted to analyze this graph or analyze something or work out the decay constant, if you're given variables for n or n naught, you can actually plot a straight line graph and do a bit more analysis on that.